All right, Titans, welcome back. Hope you had a nice spring break. Hope you're doing well. Hope you're healthy and safe. We're disappointed we're not going to be able to see you guys in person the rest of the school year, but we hope that you'll continue to do your best to learn this material, and we'll continue to do our best to help you guys, and hopefully we'll have you prepared for IM3. So let's keep working. The goal this week is to review the things we had done the week before spring break. So we're going to emphasize solving by factoring, solving by completing the square, and solving using the quadratic formula. So if you're already really good at those, this will be an easy week. If you were struggling a little bit, hopefully this will help you get you to the next step so that you fully understand what we're doing. For today, we're going to focus on solving by factoring. But before we get into factoring, I want to make sure we're very clear on what exactly a quadratic equation is and that we understand the standard form. So first off, standard form is when we have ax squared plus bx plus c. So quadratic means our largest exponent is 2. And then standard form, we have to have the ax squared in front, the bx goes second, and then our constant goes last. When we're graphing, sometimes we'll have y equals in the front. Sometimes instead of y, we'll use function notation and we'll have f of x in the front. But when we're solving, our f of x or our y always needs to be 0. So we just rewrite it as ax squared plus bx plus c equals 0. So when we say get the problem in standard form, it's essential that we set it equal to 0. That's very important. All right, along with the a, b, and c, just want to make sure we're good at identifying our a, b, and c values. I have 4 examples here. For this one, 4x squared minus 8x plus 3, our a is 4. Notice it's not 4x squared, it's just the number in front of the x squared. So our a is 4. Our b, because there's a minus in front, we have to include that, so it's a negative 8. And then our c is just a positive 3. We also call the c our constant value. So anytime we refer to a constant, that means it's the number with no variable attached to it. Okay, this next example, our a value is positive 8. Our b value is negative 12. And our c value, this time there isn't anything there. So our c value is just 0. In this example, our ax squared, there's no number there, but we know that we do have an x squared. So that means our a value is 1. Our b value, we have to be careful here not to put negative 49 because our b needs to have a variable attached to it. And this one does not have any single x. So our b value is 0. And then our c value, our constant, is the negative 49. And then finally, on this last example, we have to be careful because in order to identify our a, b, and c, we need the problem in standard form, which the problem has to equal 0. But this clearly does not equal 0. So we need to move the 7x and the negative 8 back to the other side. So we're going to subtract 7x. And then to move the negative 8, we will add 8. And so our new equation becomes 3x squared minus 5x minus 1 equals 0. So now that it's in standard form, we can now identify that our a value is 3, our b is negative 5, and our c is negative 1. So just wanted to review that vocabulary before we got into factoring. All right, solving by factoring. The main time we're going to use it is if the problem looks factorable. And sometimes it's hard to know if it's factorable until you just start to factor it. But if it looks factorable, it's an option that we can use. The other time you would want to use it is if we ask you to solve by factoring. We want to see that you can do this method. That would be another time to use it. As far as how to use it, there are 3 steps. The first step is to put it in standard form. So we need to make sure it's equal to 0. So this one's good to go. But this one is not in standard form, so we'd have to put it in standard form. Second step is to factor. So factoring, we can either take out the GCF or we can use the box to factor using the reverse area model. And then the third step is the zero product property, which is where we set each factor equal to 0 and solve. So example number 1, I notice that it doesn't have a C value, which means I can always take out a GCF. So for this problem, our greatest common factor is x, which means to get back to x squared, we can do x times x. And to get plus 6x, I need x times a positive 6. So done, it's already factored. Step 3, set each factor equal to 0. So I'm going to take this factor here. I'm going to set it equal to 0. There's nothing left to solve. That is one of our solutions. And then the second factor, x plus 6 equals 0. This is not solved yet, so I now have to subtract 6 from both sides, and x equals negative 6. So again, with quadratics, you can get 2 solutions. It's also possible to get 1 solution, or it is possible to also get 0 solutions, but this problem had 2 solutions. Number 2, we mentioned that it's not in standard form. So the first thing we want to do is turn this into a 0. So we're going to subtract 13, and what we do to one side, we must do to the other. 12x squared minus 5x minus 3 equals 0. Then we're going to factor it. And I can look for a GCF, a greatest common factor, but there is no common factor for those 3 terms. So I'm going to go straight into the box. And it's been a little while since we've done the box, so this will hopefully be a good review for you. We remember that our first term goes in the first box. Our last term goes in the last box. And then we need to multiply those 2 boxes together, which is negative 36x squared. And then our unknown boxes not only need to multiply to the negative 36x squared, but they also have to add to a negative 5x. So we always add to the middle, and we multiply to the product of the first times the last, which is negative 36x squared. So now I got to brainstorm. Think of 2 numbers that multiply to negative 36. Multiply and then add to negative 5. And after I think about it for a little bit, I come up with negative 9x and positive 4x, which those multiply to the negative 36x squared. And if we add them, they do add to a negative 5x. Once we've found these 2 boxes, we can now figure out what our factors are around the outside. In my opinion, the easiest way is to start with the GCF of the top row, which for 12x squared and negative 9x, my GCF would be 3x. And then I know to get 12x squared, that's going to be this spot up here. So 3x times 4x. To get negative 9x, I need 3x times negative 3. And then to get 4x, I do 4x times positive 1. So my factors end up being 3x plus 1 and 4x minus 3. If we were factoring, we'd be done, but we need to now solve it, right? So we need to set each factor equal to 0 because the problem is equal to 0. So I'm going to take this first factor, 3x plus 1, set it equal to 0, subtract 1 on both sides, divide by 3, and x equals negative 1/3. And then for my second factor, set it equal to 0, add 3 on both sides, divide by 4 because we want x, not 4x, and we get x equals 3/4. So 2 different solutions, negative 1/3 and positive 3/4. All right, we're going to go ahead and do 4 more examples, just to give you a wide variety of the different types of problems you might see. The first thing that jumps out at me on number 3 is that all of these are even, which means I'm going to have a common factor. If by taking out the common factor, it's going to make the rest of the problem simpler. So I always want to take out a common factor if there is one. So the common factor on this is 2. which will leave me with 2x squared minus 11x minus 21 equals 0. Now that we factored that out, we can take the remaining quadratic and factor it using the box. First term, first box. Last term, last box. Multiply those together to get negative 42x squared. And then we know that these two boxes have to add to the middle, so negative 11x. So now I got to brainstorm. What would multiply to negative 42x squared but add to negative 11x? Well, I know if they multiply to a negative, I have to have one negative and one positive. And I know that when I add them together, their absolute value is going to be 11. And since it's a negative 11, my bigger term will be the negative. And eventually, after I brainstorm, I figure out it's going to be negative 14x and positive 3x. Those will add to negative 11, but they multiply to negative 42. Take out my common factor of the top row, which they both have x's, so I can take out x, and they're both even, so I can take out 2. So 2x is my GCF of the top row. To get 2x squared, I need 2x times x. To get negative 14x, I need 2x times negative 7. And to get 3x, I need x times positive 3. So we get final factors of 2x plus 3 times x minus 7. And since we're solving, equals 0. Now we take each factor, set each factor equal to 0. So I take my 2x plus 3, set that equal to 0. Subtract 3 on both sides. Divide by 2. And I get that my first solution is x equals negative 3/2, or negative 1.5. And then with our second factor, you might be able to recognize this one pretty quick. It's positive 7, right? Because 7 minus 7 is 0. But if we show our work, we just set the factor equal to 0, add 7 on both sides, and x equals 7. So again, two solutions. Problem number 4. Step number 1 is supposed to be put in standard form. This one was in standard form, so I just went ahead and started factoring. And just a side note, this 2 here, when we factor it, we can bring it down as part of our factors, but because there was no x attached to it, we don't get a solution from it, so it actually becomes pretty irrelevant to the final solution. But anyway. All right, so back to this one. It does not equal 0, so what do I need to do? I need to set it equal to 0, so I'm going to add 6 to both sides. X squared plus 9x plus 14 equals 0. I look for a common factor. I don't have one, so I jump straight into the box. First term, first box. Last term, last box. Multiply those together, which it's really multiplying the first term and the last term, right? Because those are the two terms we put in. We need to multiply to 14x squared, but we need to add to the middle term, so we need to add to a positive 9x. Multiplies to 14, adds to 9, that's going to be 7x and 2x. And again, which box you put the 7x and the 2x in doesn't matter, you'll end up with the same solutions at the end. Common factor of my top row is x. X squared, I need x times x. 7x, I need times positive 7, and to get 2x, I need positive 2. So our factors, x plus 2, x plus 7, set it equal to 0, which is our reminder that we still need to solve it. So I set each factor equal to 0, solve it, x equals negative 2. And then same thing here, take my second factor, set it equal to 0, and my second solution is x equals negative 7. If I wanted to check my answer and make sure I'm correct, if I plug in negative 2 for both x's, this would end up being equal on both sides. Same thing if I plug in negative 7 for both x's, it'll be equal on both sides, so they both work. All right, last two for today. Now look at this problem, and holy cow, those are some big numbers, right? If I multiply first times the last, that's 1,000. So I need to multiply to 1,000 and add to 70. That's crazy. So let's go ahead and make it easier for ourselves and take out our common factor, which is 10, which now makes my quadratic only x squared plus 7x plus 10, which is going to be much more manageable. Put that in the box. First term, first box. Last term, last box. Multiply those together. Add to the middle. Multiplies to 10, adds to 7. Well, that's positive 5x and positive 2x. Take out my common factor from the top row. Figure out what multiplies to give me the rest, and I get x plus 5, x plus 2. Write down my factors. Set it equal to 0. And again, you've probably discovered the pattern. Opposite of this one, and then divide by the number in front if there is one. But I still think it's good to show you the work. Set the factor equal to 0 and solve it. X equals negative 2. Same thing on this one. We're going to set it equal to 0. Subtract 5. X equals negative 5. All right, final example for today. This one is not ready to be factored yet. Why not? Because we've got 9x there. What do we want it to equal? We want it to equal 0. So I need to get rid of 9x. And if I'm going to get rid of 9x on this side, where do I need to put it? Well, I put it under the b, right? Because anything with the x, that's a like term with our b. And I get 4x squared. But then what happens with this? It's gone. Still have minus 25 equals 0. So you might recognize this as a difference of two squares. So if you do recognize that, good for you. That is awesome. This is where we can use a shortcut, and we can just say, hey, the square root of 4x squared is 2x. And the square root of 25 is 5. And in order to multiply and get a negative 25, we need one positive and one negative. And we have now factored it. Or, if you don't like that way, or if you haven't memorized that, we can also rewrite this as 4x squared plus 0x minus 25, and we can use the box. So if we use the box, first term, first box, last term, last box, multiply those together, and this time we need to add to 0. So if they multiply to negative 100 and add to 0, that's going to be positive 10x and negative 10x. Take out my common factor of 2x. Multiply to 4x, I need another 2x. Multiply to 10, I need positive 5. Multiply to negative 10, I need a negative 5. So I end up with 2x minus 5 times 2x plus 5 equals 0. Hey, same thing I got using a difference of two squares. And then once we have our factors, we're going to set each factor equal to 0. So 2x minus 5 equals 0. Add 5. Divide by 2. X equals 5 halves. So again, the shortcut you might have been picking up on, opposite of this number, so opposite of negative 5 is positive 5, and then divide by the front if there is a front, so divide by 2, positive 5 over 2. All right, same thing works here. Opposite of 2 is negative 2, and then this is just a 1 in front, so you don't have to put over 1. All right, opposite of 5 is negative 5 over 1. All right, so if I use the shortcut on this, opposite of 5 would be negative 5 over the front term, which is 2. Or we can show the work. 2x plus 5 equals 0. Subtract 5. That's why it turns into a negative 5. And then divide by 2, which is why it's over the front term. And we end up with positive 5 halves, and negative 5 halves. All right, there's today's review on factoring. Hope you guys are well. Have a great day.